Okay, so the next test is for checking for a reset signal on this AA card. Now, get it away, tie up a little bit. So the TP2 is a reset pin there. So it's currently high. Oh, there we go, there's a pulse, negative pulse. So yeah, there is something going on there. Still negative pulses from time to time. So that seems alright. So nothing wrong there. What's the next thing? I've got to try and find a whole bunch of these connections. This is going to be interesting. So in capacitance mode, I am. Terminals open, which they are. What if I have to completely open them? Don't know. So it's D blank at A8 pin RL, CDC at A8 pin DR, or SDC A8 pin CR, always at low level. Okay, I've got to find these, don't I? RL. I'm pretty sure it's not marked on the back of the board. It is not. Or is it? No, it's FL and LL. That's a bit inconvenient. I suppose they're not on the front of the board either, are they? So you think they would be. Just excuse the back of my head. No, there's nothing. There's no test points on the front either. So I'm going to have to do it at the card edge, which is a bit of a pain. Especially when you don't know where the hell they are. So I'm going to have to look at the diagrams and trace those back and figure out where they are. DR, I can probably find DR. That's on that side. Maybe the fourth one. Yep, that's actually marked. So that's pulsing. So that's looking okay. And CR, I can check that one too. I can get that one. That's that one there. Pulsing. Let's got pulses there. So DR and CR look okay. RL, I don't know where the hell that is. I'm going to have to find that out. I mean, S is the last one, so let's just try next to S, shall we? See if that looks promising. No. Who would have thought? But no, it's just. Yeah. Just trying random points. Nothing, I can't really tell. So I'm going to have to look at this and find out where the hell that DR. Sorry, not DR. RL link is. So I'll look at the next test before I go and look at that. So this next one is WTGT at A3 TP4. TP4 is where? Ah dear. Test points, where are you? One. Why is this flashing? TP4's there. Okay. So that's TP4. Just get my probe hook thing. Just hook it on. Right. I can mess around then. Right. So there's obviously multiple signals there. So that is TP4 always at high level. Nope, that's jumping around. I've also got to get. That's waste time getting it, wasn't it? UCD at A8 U10 pin 9. So U10 is where? That's 11, 6, 7, 8, 9, It was 10. Oh my dear. Oh, this is not very good, is it? Right. 3, 5, 11. There's 10 there. Right. So that's your 10. So I want, what did I say I want? Pin 9. Pin 9 of your 10. So this is a 7-pin chip, is it? 2, 4, 6, 8, 9 is that one. I think that's right. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 9. That's low. That's fine. I'm pretty sure I'm getting on there okay. Let's get a probe instead. No, that's low. So that's right. Or blank A8 4R. So pin 4. There. That's low as well. So the second test looks okay. So I just need to check that DR, no, not DR, RL pin, and figure out where the hell that is. And then I'll come back. Okay, RL tracks back to being U11 pin 4. So we'll test it there. Seems like an easier point to test it, really. I'm not quite sure why they made it so hard. So U11 pin 4, that's U11 there. So pin 4, that one there. What is it doing? Looks like it's got some variations in what it's doing. Just making sure I'm definitely pushed in. Yeah, that's fine. So that passes that test as well. No issue there. Right, the next test is to check for OFN. And so I've got them capacitance mode still, and OFN, which is pin 3R. So pin 3R. Yes, I'm seeing something there. I'm seeing logic signals, so it looks like it's probably okay. Go a bit slow with that so I can see pulses a bit better. Maybe I can, maybe I can't. Here we go. Let's just do a roll. So, yeah, that's fine. That's what it's doing. It's pulses. It looks fine there. So, also want 5R, which is going to be that one there. Yeah, that's doing pulses as well. Pretty big pulses actually. That's like 10 volts. That's weird. It's doing 11-volt pulses. Okay. Might have to look at that and see if that looks normal or not. And I'll do AR as well, which is on the back. Pin just here. So that should be that one there. Yeah, that's pulsing too. Again, that's around 10 volts or so. Actually, well, that's about 12 volts. So yeah, that's interesting. Alright. Also got to do at 2R as well. And 2R is that one. That. Is it logic pulses, or is it me jiggling the probe around? It looks like a pulse. Yeah, that's a pulse. Okay, that's alright. And when test signal level has changed, TOL at A3 3R. So 3R is that one. Test signal level. I can't tell. Let's slow us down again. Has got a three division high pulse. Yeah, there we go. Yeah, there is definitely a change in digital there, so that's fine. That seems to be working. Right. Next thing. Set to trigger internal. Right. Trigger mode auto, or circuit mode auto. Auto. Range hold on. Unknown open, or short open or short for C. So open for L function, so I'll do that. Do step signals at 80 TP4, 88 TP4, and TP5 look like that. Well, okay, let's have a look. TP4 first, which was here. Short pass, long pass, short pass, long pass, short pass. Yeah, they kind of do. Kind of, yeah, I suppose. Short pulse, the first short pulse looks different now. It's longer. So maybe it depends on what range it's sitting at the time. It seems to be fluctuating around a little bit. So yeah, it kind of looks like that. TP5 should be like a square wave. Yeah, no. No, they're not exactly the same, are they? Those are not the same. Okay, changing test frequency affects that. Let's have a look at this and see if it changes. That's very different now. Come on. Let's do a single, there we go. Well, no. The test frequency does make quite a difference to it, so that's interesting. I might just see if I can get a setting which matches the description. Hold on, let's put it back and roll again. So that 1 kilohertz is not agreeing with it. So it doesn't look the same. Now maybe I should try different mode. Let's try shorting those and doing a different mode. So as I say, short in capacitance, was it? Short in C function. Alright, try it again. Looks very similar to the first one. It's not exactly the same. The example diagram. See, the example waveforms for this one here, the very first pulse in that set of 3 is the same size as the third pulse. Right, they're both short pulses, and here I've got the first pulse is longer, so that doesn't look right. And this one here is supposed to be more like a square wave, but that's not what I'm getting. I don't know. It is kind of right, but the example is a square wave. So I don't know. Okay, we'll look at the next thing, assuming that's got an error, shall we? So that is following signal A8, U17, pin 10 and 12 look like a negative spike. Okay, or negative pulse. So U17, which is where? That's 18, there's 17 there. So on pin we'll say 10 or 12. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so pin 10 is that one. No, pin 10 is just high the whole time. Unless I'm not seeing it because it's sampling too slowly. Let's do this. 8, 9, 10. Stick on 10 again. Come on, stop slipping off. Oh dear, it's going to drive me nuts slipping off. Right. There is a pulse there. Right. See? There is a pulse going on there. I've got persistence turned on, which is why you're getting a weird display. And pin 12, which would be that one there. Yeah, there's a pulse there. So if the waveform at TP4 and TP5 don't look correct, then it says to replace U18, which is this one, 74LS107N. Well, the pulses look different. I don't think they were wrong completely. It just didn't look exactly right as per the example. So I'm not 100% sure on that. So I'm going to just make a note of that as a suspicious aspect of what could be going on. So that is TP5. So it's section 8.12. TP5, TP4 and TP5 odd. So I put suspect a U18. U18 may be bad. Potentially, or it could be nothing. Yeah. Okay. So it was a 107N. I might have some of those. I've got all sorts of parts. 107 sounds familiar. I may have some. I might have to check on that. Again, that's one of those things I'll probably replace it, put a socket in, and if it doesn't change with the replacement, then put the original back in again. That's probably like it's not easy to get one of these chips out without damaging either the pads or the chip. I mean, you've got something like this which is double-sided board. It might even be multi-layer, this board. I'm not sure. It's definitely double-sided at least. Actually, I think it's probably only double-sided, to be honest. Yeah, I think it's only double-sided board. The no way to get this out without damaging them is to just cut the legs off and take each pin out individually. But of course, I want to keep the IC. I'm not sure the IC is bad. I don't want to destroy it getting it out. So I have to desolder it much more carefully and just try and do each leg and free them all up each time. And it just takes more care, and there's a higher level of risk involved with damaging the board. But as long as you don't rush it and you take your time, you just make sure each pin is free, then you'll probably be okay. You don't try and pull the thing off the board, because if you try and pull it, you end up lifting traces off or ripping pads out or whatever. You know, you never force it. You just let it just fall out, just gently by hand, just wiggle it a little bit, and just if something's attached, it won't come out. You know. Anyway, right. That's enough waffling for that. So I might look at replacing that. I'm not convinced that the example diagram is exactly correct, because this is an old scope diagram. The scope quality of this is far beyond what was used at that time. So yeah, the accuracy is very different. But I'll show you the diagram it's supposed to be getting. Actually, I'll do that. There you go. So there's the example drawings of the waveforms it's supposed to be getting. So there's the TP4, you can see at the top there, and you've got a TP5. So as you saw, that isn't exactly what I was seeing. So TP5 is by far the most different. So yeah, and then we went down here and we checked that, and those pulses, and those are okay. So I don't know, they were alright. So those pulses correct, so suspecting that A8, U18, etc. Well, what does etc. mean? You know, I wish it just you know, to say, hey, check all these ICs. But anyway, we'll see how we go. The circuit diagram for the A8 board. Now, what I want to show you is actually just off the side here, so it's on the next page. Let's go here. Zoom this in a bit. I'll get into our program and zoom in. Now, that section I'm working on right now, that's TP4 and TP5 just here. Alright, zoom in a bit more. So the pulses I was getting at here weren't correct. TP4 had that longish first pulse, and TP5 wasn't really giving out a proper square wave like it would expect to. It just didn't seem right. Not against the example diagram. So it said to replace U18. Well, the only thing here is U18, so okay, I don't mind doing that. I'll just replace that part. I do have one, well, a similar one. It's not an LS version, it's a normal one, so that may or may not have an influence on things. Again, I was going to put a socket in and try it. Now those two input signals, they come from pin 12 and pin 10 of U17. Okay, so those are the two pins I also checked for pulses, and those pulses were there. Whether those pulses were actually correct, I don't know. Maybe, but those waveforms are wrong, so I'm going to start with this first. I'll replace this chip and see if that changes anything, and if it doesn't, then I might have to look at U17. Hopefully not. And I'll go to this testing procedure here. So the next page up must be here. I've still got it open and I'm recording. So this is what I'm following through, is this process here, and as those waveforms there I should be getting. Let's bring up a bit more so you can see it. Get that one. Alright, so those are the waveforms that should have been getting, and I wasn't getting there. So this one here is very different. This one here is slightly different. That first pulse there wasn't right, and it's more like, it should be more periodic like that. So I'm going to replace that chip and see if that fixes anything. And then that's the next bit I did, is checking for those pulses, and yeah, I was getting those pulses, but they weren't as periodic as this either. They were just random pulses, so that may be why this isn't periodic. I don't know. So I'll start with this. It says U18. But failing that, I might have to look at U17, U4, U3, U8. So if I go back to there, so 7438, okay. So 8 is the control ROM, which I really hope isn't bad because I can't fix that. 17, U3 and U4. Alright, so obviously got NAND gates, inverting gates, and whatever the hell that is. I don't know what U17 is. So I was going to do this one and then maybe work backwards if I still can't get the right waveform, but something's not quite right there. That's actually one of the first things I found which looks like it's potentially got a problem. Alright, so I've taken this A8 card out. Now I've got to take out U18, which is that one right there. So I'm just going to start off with putting some fresh solder on, because that always helps. Just helps it to flow out a little bit. It just gets it right through, gets the heat through, just freshens it up, and just makes it a little bit easier to desolder. Having a nice thermal mass of that solder as well also helps it too when it comes to trying to get it to desolder. It all just helps. When you try and do something like this, which is a little bit tricky, then you know it's important. It does seem a bit counterintuitive to be actually adding solder to something you want to take out, but it's fine. I find it helps to actually get it to work. Put some fresh stuff on there, it just melts a bit easier. And flows a little bit easier. And flowing easier is important when you're trying to desolder it. Hope my hand's not in the way too much. I've actually got an idea about converting my soldering station here to use the TS100. as the actual iron for it. But because it's got a temperature readout on there, I'm not quite sure how it's going to go. It might have to just convert it and do something, just have power come straight out to it or something. Because it would be quite nice to use that iron, because it worked better than this thing. Yeah. Anyway, if you haven't seen the TS100 review I did, then I did it recently. There's a video for it. Let's try and get untangled. Right, let's see if I can get this thing out. Let's try and get it so you can see, hopefully. Eh? I'll do that. Like I said, you've got to be really careful to make sure that these are definitely detached. Otherwise you end up damaging the board when you try and take the part out. It's an easy mistake to make. I was checking each pin. What I'm just doing is just giving it a wiggle afterwards. Nothing you'll see on the camera, but it moves freely once you've desoldered it properly. So that chip is basically falling out. It's got a couple of pins there which aren't quite off. It's one of these bottom ones here, I think. That one there, that one there, that one there, I think. Yep. So it's just almost there. I think this last pin here was just caught again. Yep. And it's out. Right, so sorry about the noise, but you know, that's the way those things work. And so the chip is out. Now what I can do is get my little component tester again and see what it thinks of this chip. Drop that in there, clamp it down, turn it on. Maybe I'll do that. Do a search. Not found. Okay. Can't find that device. Let's just try this one. This is an NTE part, which is a little different. Error again. Not found. Doesn't recognise this one either, so maybe it's not in its vocabulary. That's entirely possible. Anyway, we'll put a socket in, and then I can just plug and play and see what goes on there. So I'll just drop that one in there. We'll solder it on and go from there. I'll stick some flux on here first, eh? These pins weren't the best before, so let's give this a polish up. Last one of these I had no trouble soldering it a little bit because the pins were slightly oxidised. Just run it across with my fiberglass brush just to freshen up slightly. It'll help a little bit. Then I'll stick some flux on it as well, and that should do the job then. Right. This pen is just about out. I've just got to figure out what I did with my new ones. I've got some new pens, and then I can find them now. I've got them somewhere. This pen is that's at it, I think. Over here. There's a little bit in there still. No, it's coming out. There's some coming out. That's all right. We'll carry on. Might as well make it easy for yourself by using a bit of extra flux. Pin 1 that end. Of course I bent one of those pins when I was playing around with the flux pen. Right, solder this in. big ugly glob of solder. I'll fix that in a minute. Just want to get the thing secured onto the board, then I'll worry about doing it nicely. Okay. Being a double-sided board, you have to put a little bit of extra dwell time on the pins just to make sure the heat can get right through the board, right down the pin, right to the other side, so you get a nice solder joint on both sides. If you do it too quickly, then you're relying on a via to actually, well, the through hole itself, the plated through hole should be more precise. You're relying on that to actually conduct the signals through the board, and that's not the best thing to do. It's best to try and get solder on both sides, so it's actually plugged through the through hole, if I can say properly, and hopefully solder both sides of the board. I don't know why this is showing up on camera. I'm probably blocking it with my iron. Anyway. You can imagine me sitting there soldering, you can picture it or something, I don't know. Doing out the soldering looks like. As well. Alright. Kind of see joints that side. Yeah, there's solder right through. Just see underneath the chip, there's one there, probably needs a bit more. Third pin down that side. And there you could use slightly more. Yeah, that's better. Okay, let's clean it up. And my little cleaning toothbrush has turned up. I'd used it last in the kitchen when I was trying to recover one of my bits of test equipment which got flooded in January when the flood happened. So I left it sitting on a windowsill. Go figure. Found it yesterday. So that's quite nice. Get that back. Well, get the flux off. Yeah, I'll probably do. Alright. Let's drop the replacement part in, and of course the legs aren't straight for that. Better bend them around a bit. Hopefully it's in camera. I'll just put it on a bench surface and just tip it over. Put the pins down and tip it, and you can align the pins pretty well. Though I do actually have an IC straightener somewhere. I did know where it was, but since the flood, things are not where they used to be. And I don't know where the hell it's gone right now. Alright, so let's put that's the NTE part in there. So fingers crossed it's going to work. And we'll see if it changes anything as far as these signals go. So I've got the original part still there. I can put that back in if I need to. Or if this proves to be no different. If it proves no different, then I'll put the original part back in again. Right. Let's try and get this all in shot again. 12 minutes of video. Wow, this is going a little while. Okay. Should be good enough to see. Find the scope probe, turn it on, and see if anything has changed. So what was I going to look for? TP4 and TP5. Yeah, TP5. Let's do a roll mode again. Get down low enough, come on. Doesn't that look different? It's different. Oh, I've got those terminals unshorted. Oh, let's just change that. looks the same. So in inductance mode those terminals should be open and those look the same as they did before. Nothing's changed there. So it looks like that chip isn't the issue. If I short them again just to prove it and do it on capacitance again. Short those on capacitance. They should be pretty much the same again. Yeah. Yeah, so that didn't change anything. So it looks like that chip wasn't the problem. Damn. Oh, we'll put the other one back in again. And we'll pop this one back out. Where's my IC pullers? No, I don't know where they are either. Oh, hopefully I can get in there with this. There we go. Just put it behind the chip like that and just lever it slightly out. Nice and gentle. There we go. Right, this is a long piece of video. So I'll put this one up here. That one didn't make any difference, so I'll put the original back in again. Make sure the pins look okay. No lumps of solder on them. There is a little bit on that one. Just run that across on the iron, clean off a little bit. Make sure there's no lumps. Yeah, it's fine. Okay. We'll pop that back in the socket. Because obviously this chip isn't the problem. Yeah, but that's why I put sockets in, because if it's wrong, it's easy to swap it. You know, it hasn't cost me a part. What it's cost me is a socket, and yeah, sockets are cheap. Parts may not be. So, and if you ever need to come back and just recheck, you can always do a substitution later on. I wish better equipment had sockets in them. I mean, there's pros and cons. So the benefit is that it makes it easier to work on because you can take a part out and drop a new one in. The con is the sockets can get weak over time and get bad connections, or to get a bit of oxidization on the pins, things like that. You got to put, you got to try and rebed things and reseed things. So that can be an issue. We're trying to do long term. In a way, not having sockets is better. It's more reliable, but it makes it harder to work on. Anyway, let's just recheck this again. Back on inductance because it's open, and yeah, it's no different. So that's fine. At least I know it's not that chip. I might be chasing my tail on something here, which is, which actually isn't an issue. I just don't know, because you can't always completely trust the manual. I mean, it may give an example, but depending on how you interpret that example, it may or may not be right. So yeah, anyway,